AP Stats students. I thought we would do the example of this next procedure a little bit differently. The template that you should have watched before this video, your green template, covers the details for how to do a two-sample t-test, and there's nothing really new about it except for the fact that it's the difference of two means instead of two proportions, but all of the formulas that we use with intervals are going to apply over here. So it's a great example to try. I hope you actually tried it before you watch this video. What I'd like to do is show you an example of one that would get a full credit score and then one that would have gotten a 3 instead of a 4 out of 4 on the AP exam, and talk about the scoring guidelines, the specific things that AP is looking for when you do a hypothesis test. So if you want to write at the top that this is a two-sample t-test example, just to kind of have a good place to look at in your notes. It should look like the right side of your template. So as you're reading through it, you should have seen that we were comparing cholesterol levels for two different types of drugs. There's the standard drug that they've always used, and they have this new drug they're trying to see is it better at reducing cholesterol levels. So this is how they ask the question oftentimes in AP when they want you to do a hypothesis test. They'll say things like, does the new drug appear to be more effective than the standard treatment in lowering mean cholesterol level? Give appropriate statistical evidence to support your conclusion. Nowhere does it say do a hypothesis test. It doesn't always give you an alpha level to decide whether it's significant or not. They allow you to choose your own sometimes. So that's sometimes the tricky things for students is they don't realize when they see that, oh, they want me to do a whole hypothesis test. So if you don't do all of those parts, you're going to lose quite a bit of work, quite a bit of credit, excuse me. So it'd be good to take a minute. I always find it hard when they like tell all my numbers in a big old paragraph. So I like to organize my stats to start with. And I'm actually going to show you in a minute how you can use your calculator and get an answer that would be acceptable, even though it will be slightly different than the answer that we're going to get if we do it all by hand and using the formulas we've said on the notes from Ms. Milsick. So I'll just go ahead and show you what I got. My hypotheses. I decided to do the new drug minus the old drug because we're trying to reduce cholesterol better. So the average cholesterol should have been higher in the new group. Average reduction, in cholesterol should have been higher in the new group than in the old group. But you could have switched this and done a less than. And then my assumption conditions, pretty simple. Random assignment, less than 10%. Ooh, forgot one. The groups were independent. That's just that thing I've been trying to drive home, that we don't want to think about this as being paired data in any way. It's not like somebody tried the new drug and then waited a while and tried the standard drug, like some sort of a paired match pairs experiment. Just two completely randomized separate groups, so we can say they're independent groups. Our samples were large enough, we can assume normality, and I named my test the two-sample t-test. The mechanics are pretty simple. I actually did the standard error inside the test statistic formula, which if you hate that, you can separate it out, but it just means that you don't round at all. These are the difference in my X bars, and that's my test statistic. AP really wants you to write your degrees of freedom down anytime you're using t-models. So if you didn't do that, you might actually get partial credit on your mechanics. This is how I got my p-value using TCDF, and I can show you that real quick. Went to second bars, TCDF, and 3.9299, 49 degrees of freedom. That is not what that says, sorry. I copied it down from somewhere else. My bad. 1.375 times 10 to the negative 4. Oh, that's what I did. I just had a 1 there instead of I should have had a 1 there instead of a 4. That was just my bad. Copied it down wrong. And then finally, p-value low, reject the hoe. We have sufficient evidence that the new drug is more effective in lowering the mean cholesterol level. Make sure you got that word mean in your sentence, indicating not an individual person's cholesterol level, just the average cholesterol level. So this is Miss Meadows, and Miss Meadows would definitely get a 4 on hers, but I want to show you why AP would give me a 4 and the specific things that they're looking for. So first off, they broke up the solution into 4 parts, which is, you're going to get an E, P, or an I for the 4 parts. The first is the hypotheses. So you can write them in any of these 3 ways. A lot of students at other schools write them like this, where they say the null is that the 2 means are equal, and the alternate is that one mean is higher or lower than the other. I hope everyone realizes mathematically that's exactly the same thing as centering at 0 and saying less than or greater than 0. The other thing that they do, and actually I did that too, I defined my parameter as 2 separate means and then used it, talked about the difference up here. So that's an okay thing to do. If you wrote mu n minus mu s is the difference in the mean reduction in cholesterol level for new and standard, totally fine. Just make sure it's very clear which variable is which subscript. The naming of subscripts using something different than 1 and 2 is preferred. So that's part 1. Part 2 is looking at your test name and checking your assumption conditions. So they need you to name what test you're doing, and that's part of your credit for part 2. Or they need you to write the formula out without any numbers plugged in for the test statistic with the standard error formula in the denominator. So it's kind of an interesting thing. They say you could do one or the other. I would expect my students to do this, but this is an acceptable way of indicating which test you're doing. And then they need you to have said random assignment, and then either normal population assumed or large samples, something like this. Both samples were large, 50, and there was random assignment of treatments. So in terms of assumption conditions, they don't even mention the 10% condition here, so I guess they weren't looking for that. Next, part 3 is a little confusing on the scoring guidelines because there's more than one way to deal with the p-value. But here's my test statistic that I copied from them, actually. But you should have been doing that same thing. If you do the standard error off to the side and then put it in, you might get a slightly different test statistic. Also, if you did new minus standard, you would have had a positive t-score and you would do a greater than. So that would be different, and that's completely acceptable. It just needs to be synonymous with your alternate. Then here's when it gets a little crazy, and I don't want you to worry about all of these different options. You would have done this option. The degrees of freedom were 49, which is small n minus 1, and then using TCDF gotten this p-value 0.00014. So there are other options, and I want to show you that real quick. One option is to use your test menu, and they do something weird with degrees of freedom. So if you want to do it with me, you go to stat, over to test, down to 2 sample t-test, and you'd put in your stats, because we don't have data, for X bar, S, and N for each of your groups, and you want to do it in the order in which you did it with your null. So I did the new one first, so I'll put in 18 for the mean, 12 for the standard deviation, and 50 for the sample size. For the standard drugs, I did 10 for the mean, 8 for the standard deviation, and 50 for the sample size. And then the alternate is a greater than. It asked you if you want to pool, and Ms. Milsick didn't say anything about that on the green template. So generally the answer is no. If you try to do that, you have to think about something that's not necessary to think about. So we just tell you, say no to pooling whenever it asks, for means at least. And then when you hit calculate, we do get the same t-score, but the p-value is a little bit smaller. And your degrees of freedom is this psycho-crazy decimal. Where is that coming from? There is another way more advanced, not part of our level of AP Stat, a calculation for how to get the degrees of freedom that is always bigger than small n minus 1, but it will give you a more accurate degrees of freedom and the more accurate model. So when that happens, if you choose, and some students do, to use the test menu, then that is acceptable, and they listed it here as an option, and how you can see the p-value is different. Still low, still going to reject, but it would have given different p-values, and that's fine. The rest of these have to do with using charts to calculate your p-value. We have never done that in this class. I've always shown you normal CDF or TCDF or your test menu, but some schools do it this way, and I'll show you an example of a student that did that. And then finally, the fourth part is making the correct decision because the p-value is less than an alpha or really, really small. We reject the HO. There is convincing evidence that the mean cholesterol reduction is greater with the new drug. You can also see down here how they decide on E's, P's, and I's. They're usually looking, in this example, each part they're looking for two things. If you're missing one of those two things or it's incorrect, you would get partial credit for that part. And if you're missing both or both are incorrect, you would get an I for that part. Finally, they would put together E's, P's, and I's to get your 4, 3, 2, 1. If you have 4 E's, that's the only way to get a 4. They said if you have 3 E's and a P or 2 E's and a P, which doesn't always happen that they give this option, so that's kind of nice, then they say that is substantial and you'll get a 3. 2's can happen lots of ways. You can have 2 E's and no partials at all, so 2 E's and 2 I's. By the way, these are in any order. It doesn't have to be the last ones. You could have 1 E and 2 partials, and all 4 parts partial. That would give you a 2. Finally, a 1 would be 1 E and no partials at all, again in any order. Or 2 partials and no E's at all, again in any order, would give you a 1. Anything less than that, like just 1 P is really less than that, you would get a 0 or all I's. If you ever total up, oh no, we don't need to worry about that one. Okay, so I wanted to, last thing is to show you 2 students that got, that took this test in 2007 and what their scores were. So this is a student that got a 4 out of 4. You can see she's one of the students that uses the means are equal and one mean is less than or greater than the other mean instead of the 0. It's an acceptable way to do it, and it mathematically means the same thing. Her assumptions and conditions are over here. She never ever says she's doing a 2-sample t-test, but that doesn't matter because she wrote a generic formula out for her test statistic with the standard error in the denominator. So that counts as her second component for the assumption conditions. She mentions here the central limit theorem, so she's awesome. By the way, I'm assuming it's a she. I don't know if I'm being sexist, but it looks like a she to me. I don't know why. Anyways, she mentions that it was random. She says that both samples are greater than or equal to 30, so the central limit theorem applies. This is her 10% check. So just a little bit of a different way of doing it down here, but they're not looking for that. Here is a little confusing. Her test statistic was the same that we got. Her degrees of freedom are the same that we got, but she didn't calculate her p-value using TCDF. Her teacher taught her how to use charts to do it, so it looks a little odd, but she still got a small p-value, and that is essentially correct. That's one of the ways you can get a p-value. And then finally, her conclusion, her p-value is less than this, which means that the probability is significantly small. We're going to reject the HO and assume the HA is true. The new drug seems to be more effective at lowering mean cholesterol level. Notice how she puts that context back in at the end. So, it may be a little awkward because it's not exactly the way we do things, but it's nice to see that how other students get their scores. And one more. This is a student that got a 3. They got a 3 because of 2 E's and 2 P's. They got full credit for their hypotheses. They looked at the standard drug and the new drug, and they made it clear that the standard drug is lower than the new. So this is kind of an interesting way. Instead of defining the parameter, what is mu1 and what is mu2, or what is mu1 minus mu2, they actually describe their null and alternate in words and in symbols. So that's something that's a little different, totally fine. They only got partial credit for their assumption and conditions. They did name their test, but they did not talk about the large enough here. They just checked off and said normal, but they didn't say why. So they needed to mention the large counts of 50 being greater than or equal to 30. They got full credit for their mechanics, even though they didn't write down degrees of freedom. So I'm a little bummed by that they said they got full credit for it when I read their grading. But yeah, why didn't they write their degrees of freedom? Because it looks like their degrees of freedom is the one from the calculator, which is the 85. And then finally, their conclusions, they said, were partial. It just says with a p-value of this, we can assume that our results were significant and not due to chance. The new drug is more effective than the standard cholesterol-lowering medication. I don't like that they didn't say the word mean. And they also commented on the fact that they stated the p-value, but they didn't compare it to an alpha level of any sort. Or they didn't indicate that it was a small p-value. So just saying it's significant doesn't indicate that you understand that small is what makes it significant. All right, I hope this was helpful, and this is our last video for Chapter 10. See you later.